Good morning, guys. From last two lecture, we are going to study approximation of function. In first lecture, we have seen what is Chebyshев polynomial, and in a second, we have solved some problems on Chebyshев polynomial. Now, we shall see the next article, that is economization of power series. Okay. At first, we shall see what is a economization of power series, and after that we shall see one problem how the power series can be economized. To see what is a economization of power series, consider the power series expansion of the function f of x in the form given by equation 6, that is f of x is equals to a0 plus a1x plus a2x square plus on an x raised to n. Here x lies between -1 and +1. That means x belongs to closed interval -1 and +1, because -1 is less than or equal to x is less than or equal to 1. Now in this power series, there are some terms with the powers of x and the coefficients. The coefficients are a0, a1x, a2x and so on, an. And the powers are of x are 1, that means x raised to 0, x raised to 0 is 1. Next is x means x raised to 1. Next x square, x cube up to x raised to n. And then we shall write the powers of x in terms of t and x. We know that 1 is equal to t0x, x is equal to t1x, x square is equals to half t0x plus t1x, x cube is equals to 1 by 4 3t1x plus t3x, and continuing like this. We shall substitute all these values of powers of x in the power series which is given by equation 6. The equation 6 can be converted in terms of Chebyshef polynomial. That means in terms of t and x. Means we shall substitute and simplify, and after simplifying you will get equation of the form b0, f of x is b0, b0 means new constant, plus b1 t1x plus b2 t2x plus on bn tnx. Now this is equation 7. Equation 7 is a equation 6 written in terms of t and x. Means we have substituted the values of powers of x by t and x and simplify, and you will get the equation 6 in the form of equation 7. That is f of x is equal to b0 plus b1 t1x plus b2 t2x plus on bn tnx. For a large number of functions, an expression as in equation 7 above converge more rapidly than the power series given by 6. Means power series given by 7 converges more rapidly than the power series given by 6, and this is known as economization of the power series. That means we have to write the given power series of the function f of x in terms of t and x, because which converge more rapidly, and therefore the new power series is called as a economization of the power series, or this procedure is called as a economization of power series. For example, this is the fourth example of the chapter. The problem is economize the power series. Sin x is equivalent to x minus x cube upon 6 plus x raised to 5 upon 120 minus x raised to 7 upon 5040. This is a power series of x, of sin x in terms of x. Now we have to economize the power series. That means we shall write some terms in terms of t and x. At first consider the given power series. Sin of x is equivalent to x minus x cube upon 6 plus x raised to 5 upon 120 minus x raised to 7 upon 5040. Now obtain the value of 1 upon 5040. That means divide 1 by 5040. You can observe that its value is 0.000198 and so on. Okay. Now we shall consider this as a truncation error, and we shall eliminate this term and we shall get a new series. We shall call this new series as a truncated series because we shall eliminate the truncation error. Okay, and therefore the new truncated series is sin x. Compare with this. Sin x is equal to x, this term as it is, minus x cube upon 6 as it is, plus x raised to 5 upon 120. Now next term is eliminated because we shall consider this as a truncation error. We have eliminated this and we shall get a new series, that is a truncated series, which is given by sin x is equivalent to x minus x cube upon 6 plus x raised to 5 upon 120. This truncated series given by this first equation will produce a change in fourth decimal places only. Okay. We now convert the power of x in 1. That means powers of x in 1, that means in this series, in terms of t and x. Means we shall write the value of x, then we shall write the value of x cube and value of x raised to 5 by using values of powers of x in terms of t and x. And we have x is equal to t1x, x cube is equals to 1 by 4 3 t1x plus t3x, and x raised to 5 is equals to 1 by 16 10 times t1x plus 5 times t3x plus t5x. Now put these values in this truncated series 1 and simplify. You will get sin x is equivalent to, see the simplification yourself. I have written the equation directly. Sin x is equal to t1x minus 1 upon 24 3 times t1x plus t3x plus 1 upon 120 into 16 10 times t1x plus 5 times t3x plus t5x. And then taking t1x and t3x and t5x common from right hand side, you will get sin x is equivalent to 1 minus, because this is t1x and this is also t1x, means simplify this, you will get minus 1 by 8 and plus 1 upon 192 t1x, because there are three expression with t1x, because this is t1x, that is 1, and it is 3 upon 24. 3 upon 24 means 1 by 8 t1x, and 10 times t1x into 1 upon 120 into 16, this will become 1 upon 192 t1x. And similarly, by taking t3x common, minus 1 upon 24 plus 1 upon 24 into 16 t3x plus, and last 1 upon 1920 t5x, means you have to consider truncated series 1, put the values of x, x cube and x raised to 5, then take common t1x, t3x and t5x and finally take this sum in bracket. You will get sin x is 169 upon 192 t1x minus 5 upon 128 t3x plus 1920 t5x. Again, the value of 1 upon 1920 is 0.00052. We shall consider this as a truncation error, means we can eliminate this term, and the new truncated series is sin x is equals to, we shall eliminate last term, 169192 t1x, that means sin x is equivalent to 169 divided by 192 t1x minus 5 upon 128 t3x, and this truncated series will produce a change in fourth decimal places only, and therefore the economized series is given by sin x is equal to 169 upon 192 t1x means x minus 5 upon 128 t3x, t3x is 4x cube minus 3x, and then again simplifying this term, we get sin x is equivalent to 383 upon 384x minus 532 x cube. Okay, with this economization of power series, we shall stop today's lecture. Also, we shall complete the chapter approximation of function. Thank you.